So through the process of a electromagnetic induction. Then why we require a transformer? So the main advantage of a transformer is we can step up the voltage or step down the voltage according to our requirement. Apart from that, the efficiency of the transformer is very high. It will be in terms of 97 to 98%. And the transformer, since it's a static device, it doesn't contain any moving parts, so the losses will be less. Because of that, the efficiency will be more. So the transformers we can also use for the low power applications. These are the necessity of a transformer. Then let us discuss about the working principle of a transformer. So the transformer works on the principle of electromagnetic induction and the mutual induction. As you can see here, so we have a core. This is a core. So we have a primary winding and we have a secondary winding. To the primary winding, we are going to give the AC supply. When the current passes through the primary winding, the flux will be created in that. And because of the mutual induction, the flux will also be created in the secondary winding also. The EMF induced due to the flux with respect to primary winding is called as self-induced EMF, and the EMF induced due to the secondary EMF due to the mutual induction is called as mutually induced EMF. So here, from primary to secondary, we don't have any physical connection because of the mutual induction. So from the primary, the secondary terminal is getting with the supply. This is how our transformer will work. So EMF induced in the primary because of a self-induced EMF is given by minus N1 into d phi by dt, and E2 is given by minus N2 into d phi by dt. Then next will be a transformer ratio. How we can step up or step down the voltage? It depends on the number of turns what we are going to use in the primary and the secondary. So that's why K transformer ratio is given by N2 by N1. If your N2 is greater than N1, then it is called as a step up transformer where K value will be greater than 1. If your N1 is greater than N2, then your K value will be less than 1, then it is called as a step down transformer. So in terms of current also, we can write the equation for a transformer ratio. So as we know that from the definition of a transformer, so it's a static device which will transfer power from one circuit to another circuit, which will transfer the power. So as we know that energy can neither be created nor be destroyed, it can be only converted from one form to another. So when transferring a power from primary to secondary, the power remains constant. Only we can vary the voltage and the current. When you are going to step up the transformer, the current will be decreased to maintain the power constant, or when you step down the voltage, the current will be increased to maintain the current constant. That's why the power V1 I1 will be equal to V2 I2. So V2 by V1 will be equal to I1 by I2. So already we discussed with respect to transformation ratio, which is given by N2 by N1, which will be equal to K. That's why for the transformation ratio K, either we can write N2 by N1 or V2 by V1 or I1 by I2. So these are all the formulas what we can use for the transformation ratio. Then a construction of a transformer. If you consider the construction of a transformer, so majorly we have a magnetic core and the winding coil. So these two will be the major two parts which will be included in the construction of a transformer. So first one, a magnetic core. So the magnetic core, either it will be in the form of a square or it will be in the form of a rectangle, and it consists of two parts which is called as a limb and the yoke. The horizontal parts are called as the yoke, and the vertical parts are called as the vertical parts are called as the limb. So these are used, coarse materials are used to provide the path for the magnetic flux, and this core is made up of thin sheets, and which will be laminated from each other. So There will be two types of losses which will occur in the core. One is hysteresis loss and the other one is the eddy current loss. So generally a high grade silicon steel material is used to make the core. So eddy current loss depends on the width of the material. So how much width we are taken for the core, it depends on that. And the core is made up of number of thin laminations, as I already told, and the thickness of the laminations will be very small. It will be in the range of 0.35 to 0.5 mm. So you can see the thin laminations here. In between the thin laminations there will be insulation. It will be pressed together to form the core. And the transformer core material will be of hot rolled steel or the cold rolled steel. Then next one will be the winding. So on the core we are going to use the winding. So there is a conducting material what we are going to use. It's called as of a transformer is a winding. So it is of either a copper or of aluminum. The winding will be a primary winding and the secondary winding. For the primary winding we are going to give the supply, and the secondary side we will be connecting the load. And depending on the construction we can divide the transformer into core type and the shell type, depending on how we are going to place the winding. So if you are going to consider the core type, so this is a core type, and the winding will be, the core will be surrounded by the winding. So this is called as a core type. If you are going to consider with the shell type, so this will be the shell type, and the winding will be placed inside. So the winding will be surrounded by the core. Here we will have only one magnetic circuit path, but here we will be having two magnetic circuit paths. So this is the difference between the core type and the shell type. And one more thing here. So here primary winding will be placed one side and the secondary winding will be placed on the another yoke. But here in the shell type, both the primary and the secondary winding will be placed on the same yoke part. So now you can observe here what I have explained. So here this is the core what we have. On the core the winding is surrounded. So the core is surrounded by the winding. The last part of the core is surrounded by the winding. The primary coil and the secondary coil are wounded on the opposite limbs. It will be placed on the opposite limbs. It will be separated. So general forms of the coils may be, it may be a circular one or a rectangular one, like that. And for the thin laminations, what I told, right, between the sheets, they are going to use a laminated sheet, insulated sheets as a paper, cloth or cooling duct in these cases. If you consider with the shell type, we can observe this is a shell type, this is a core, so two hollow we have. In between that they are going to place with the windings. Both the primary and the secondary winding will be placed on the same limbs. So here the winding will occupy very small portion, and each high voltage winding is a sandwich between two low voltage windings. So both the LV and H will be placed on the same thing. So this type of construction is used for the high voltage applications.